right, hello. So I have some questions so far. Improve. Yep, so I'm just copying and pasting your questions so I don't forget. 24 and 25, so I think that's 24, 25, indirect proofs. Okay, so Sydney, could you find an indirect proof while you're waiting? So I'm going to go in order how it was asked. Sydney, you have a little bit of time to find some certain page or whatnot. Okay, so thanks for being here. I know usually we have our GBL the night before the test, so today is one extra early day. Cool, 27. And I think someone asked for 27, Sydney, so we will get to it. Cool. So graphing circumcenter and orthocenter, since that was on our quiz, and using a grid. Okay, so let's see. Here's a quick way to kind of remember a few things. 21. You guys remember the numbers too. Awesome. Okay, so for let's say we had I know I'm going to graph in a little bit, but let's say we have an acute triangle, a right triangle. I know my students, we did this maybe last week, and then an obtuse triangle. So if you're trying to find the circumcenter, and the homework is on the back of the sheet. I think it's the evens or the odds. So you would find the midpoint of one side, and then you would make it perpendicular to that side. So somewhere here, I'm going to do it fast, okay? And it doesn't have to hit the vertex, okay? It doesn't have to go through. Then I'll get another midpoint over here. This is really fast. And if you had to graph it, FYI, you would have to find slope of the original side of your triangle, and then you would want to do the opposite reciprocal from the midpoint to get your perpendicular slope. So that's what you'll have to do if it's not a nice segment. And so see the last side that's given here, this black right-hand side, that one you would find the midpoint, and then afterwards you would find the slope of that segment of that triangle, and then you would do the opposite reciprocal slope starting at the midpoint, and that will make it perpendicular. So anyway, whenever you have an acute triangle, your circumcenter will always be inside. For your right triangle, it's easier to find the circumcenter because it's easier to find the perpendicular bisectors. For instance, you would take the segment on the bottom, you would find the midpoint. So that's really easy to do on a graph. You would, really easy way is you would like count, like go back, right? So there's 2 spaces to the left, 2 spaces to the right. That's right smack in the middle. And then from there, you would go vertically because this is a horizontal segment, so perpendicular would be vertical. And then you would do the exact same thing for the second side right here. Whoops. And then you would find the midpoint. So again, you would go, like 1, 2 spaces and 1, 2 spaces. There it is, right? So you don't even have to do the midpoint formula. You could just count. Then you would go horizontally. Now, I badly drew this picture, but every time you do this for a right triangle, the circumcenter will be on the triangle and it'll be specifically on the hypotenuse. Okay, and that's the one you might see or you did see on the quiz. Last one, orthocenter. So I'm going to go really fast. That one will be outside the, what should I call it? The triangle, the obtuse triangle. That's a general look, okay? Now, same exact thing for altitude. So altitude, if you have an acute triangle, altitude has to touch the vertex and it has to make 90 degrees to the other side. So that's 1, and so when it's acute triangle, then you'll notice it's always inside for orthocenter. And then a right triangle, very similar to circumcenter. Altitude is, believe it or not, you start up here and you go perpendicular to the other side. There's one altitude. And then you do another altitude. You would start at this vertex and you would go horizontally. That's the altitude. The red and the green, they hit at one spot and they hit on the triangle. So just like the circumcenter, but it's on the right angle. And then lastly, if you had your obtuse triangle, if you started up here, your altitude would be outside. And then if you started, let's say here, oops, your altitude will be outside. It has to make 90 degrees. Oops. And so from there, I'm like, oh no, those green and red lines don't connect. So then they extend and extend, and then they will hit outside. So circumcenter, orthocenter have the same, I guess, summary, depending on what triangle you have. So acute are always inside. Right triangles are always on the triangle, and obtuse triangles would be, what am I saying? Outside the triangle. All right, so, okay. How can you tell what direction to use the orthocenter? Captain, how can you tell what direction to use the orthocenter? What direction to use? So I guess it doesn't matter. You just have to pick a vertex. So if you're trying to find the orthocenter, you're trying to find the altitude. So you pick one vertex and then you go to the opposing side, but you must make it 90 degrees to the opposing side. That's one altitude. Then you have to pick another vertex, and then here's the opposing side. So you have to make it perpendicular to the opposing side, 90 degrees there. And then lastly, just two is enough, but lastly, if you have this vertex, you go to the opposing side and make it 90 degrees to the other side. So obviously these should all have hit at one spot, that yellow spot, and that would be considered your orthocenter. So I'm not sure if I answered your question, Catton, but let me go over the original question, which was graphing. So let's say we have, I'm just going to make up some points on a grid. Let's say we had 4, comma 3. So right here, 4, comma 3. And then let's say we have -2, comma 3. And let's say the last segment would be 4, comma -5. 4, comma -5. So here is our triangle. You would graph that on the grid that's provided. And it's a right triangle, so I already know if I ask where's the circumcenter, it's going to be on the hypotenuse. I already have a prediction. So from there, what we do is it's easiest to find the middle of this horizontal segment. What number is between -2 and 4? That middle number is 1. Now, if you're not convinced, you can just count 1, 2, 3 from the left, 1, 2, 3 from the right. There's the middle, 3 spaces right to the middle. So again, +1, would be the midpoint. After you find the midpoint, then you would have to go perpendicular to that segment, which means it would be vertical. So this is our perpendicular bisector. Okay, we do it again. So it's easier to find the midpoint of a vertical segment. So you could count again, or you could say, what's the middle between 3 and -5? The middle should be -1 right here. But if you're not convinced, count it. 1, 2, 3, 4 spaces. And going from the bottom, 1, 2, 3, 4 spaces. They both meet up. So 4 spaces to the midpoint. From there, oh gosh. Now we would have to go horizontally because that will make it perpendicular to that vertical segment. So I make it horizontally. Obviously, my graph is not on nice graph paper, so it should have been on the hypotenuse. And this yellow dot, which looks like 1, -1, that would be our circumcenter. So it is on the hypotenuse. Now, if I had to find the orthocenter, even easier. So let me see if I could just go back. So back. Interesting. Okay, so now that got erased. So if I'm trying to find the orthocenter, then what we would do is we would take a vertex and we have to go to the opposing side. So that means I have to go perpendicular, which would make it this. This is your altitude. It's already one of the sides. Then I would find another vertex, which is down here, have to go to the opposing side, and this would be my altitude. So the yellow and the red meet at one point, and this is your circumcenter, which is your orthocenter, sorry, orthocenter. So it's really easy if it's a right triangle. Okay, let me catch up. Can you do range of lengths? Yes. All right, so I just did graphing. So then I'm going to go over some questions from, what's it called? Questions from the textbook. And then circumcenter, orthocenter of an obtuse triangle. Yes, Brianna, it's always going to be outside the triangle. What was the 2 graphing on the quiz? Are you talking about the front side, Matt? The whole point of the graphing was to find the coordinate as a visual. So kind of like what I just did, you're given 3 points. You had to graph it to form a triangle, and you had to physically draw in the perpendicular bisectors to find the circumcenter, and you had to physically draw the altitudes to find the orthocenter. Okay, so I'm going to turn to the homework, section 5, and it's number 3, 7, 23, 27. I'm going to go to the quiz after, and I'll talk about the range of possible lengths. Okay, and indirect proofs are included too, because that's part of the quiz. All right, so number 3, this is from chapter review, homework, number 3. Okay, so number 3 says, it says the blank of a triangle is the point of concurrency of angle bisectors. So this is what I taught my students. I have it on the middle of the screen. I have all my topics. This is Abby. So angle bisectors form incenters. So I try to tell my students, remember your friend named Abby, spelled in that way. So number 3, the answer is angle bisectors create incenters. The answer is incenter for number 3. I could do 15 too. Okay, I'll put that in. So then number 7 on the homework, that one might have a drawing. Nope, it doesn't. It says describe how all the points of baseball field that are equidistant from the second and third base. Ooh, this is a cool question. Okay, so baseball field, we have first base, second base, third base. So this is the home. This is first, second, third, and home. And it's asking, let me reread it again. Where did it go? Describe how to find all the points on the baseball field that are equidistant from the second base. Oh, okay. So this is a wrong answer. This is not the same distance from the second base to the third base. This is a little bit closer to second base than it is to third. Okay, so that's an incorrect answer. So there's a lot of points. So this is also wrong because this is way closer to second base than to third base. So that one's no good. So the first answer might be find the midpoint. So the midpoint of the path that the runner is going, so that would be equidistant because that's the midpoint of second and third. Then another point is, maybe the shortstop. They are standing between second and third. So they are right here, and that would make it equidistant because it would form an isosceles triangle. Basically, you're going to have millions of points. Well, obviously not on the baseball field because the baseball field ends. But if this baseball field didn't end, all of these red dots plus more, right, would create a bunch of isosceles triangles where the second and the third base is the base angle. So our final drawing or description would be a perpendicular bisector of the path from second to third base. So once again, the description, my best description, something along the lines, perpendicular bisector path of second to third base. And that would be for number 7. Let me see. And let's see, 27. Yep, 27 is coming soon. So I'm going to do 23, 27, and back to 15. So on the homework, 27. So oops, I skipped 23. I'm sorry. 23 first. So 23, that one we have to draw a picture. So it says triangle PQR. So draw that right away. I don't care where you put PQR. Sure, 16 as well. So it states that QM and PN are medians. We have to draw in our own medians. Median touches a vertex and the midpoint of the opposing side. It tells me QM, so I have to name this M. So there's one median. Then the other median is PN. So I have to touch vertex P, go to the other side midpoint, and then I have to call this N. So I have two medians, and then they say the intersection is called Z. Quick pop quiz. What do medians form? What do medians form? Yes. Yep, medians form centroids. Correct. So then now here's a very important fact about centroids, which is Z. Z is the centroid. From the vertex to the centroid, that pathway is the bigger pathway compared to the centroid to the midpoint. So for instance, this is 2x, and then the other pathway would be x. Okay, it's double. It's twice as big. So let's see what it says. So number 23, it says ZM. Oh, that's given. ZM is equal to 4. So they're saying this small pathway is 4 units. So that means QZ, that's what it's asking. It has to be double. So that's going to be 8. And then QM, that's the whole total pathway. You add those two numbers up, and we're going to get 12. So I hope that makes sense. I think the weird part was there was no picture. You had to draw it on your own, and you had to draw your medians as well, and also remember what part is double and what part is half. All right, okay. So the next question was 27. I'm going to back up to 15 and 16, and then after that I'll go to hinge theorem. Okay, so 27 on the homework. So that's the next page. 2 lines. Oh, this is an indirect reasoning. So it says 2 lines in the same plane are not parallel. 2 lines not parallel. Okay, then it says show that a third line in the same plane must intersect at least one of the 2 lines. So that's like the proof. This is what we're trying to show. but we're asked to do it indirectly. So step 1, in any indirect proof, there's usually 4-step model. Oops. But within the 4 steps, interesting, something just crazy happened. Within the 4 steps, there could be many steps. So step 1, we will always say assume opposite temporarily, opposite of the proof. Well, opposite of the proof would be this statement. So we're going to say the third line, if it says it must intersect at least 2 lines, that's like 2 or more, right? So then that means the complete opposite would be, this is a very fancy English way, is we would say the third line intersects neither of the 2 lines. So again, the complete opposite. Like you could be very literal. You could say assume temporarily the third line does not intersect at least 2 of the lines, right? You could say just does not. But what that really is interpreted as an English person, you would rewrite it and say, oh, that means if it's not at least 2 lines, then it's neither. It won't hit neither of them. Okay, that's step 1. And then step 2, we would say, okay, if they don't intersect them, right? So we're going to believe that. It says if it doesn't intersect, that means, because we just said it doesn't intersect, that means that those lines are actually all parallel to both. So the third line is actually parallel to both. That's the meaning of it doesn't intersect. They don't touch each other. Okay. From there, that's a bummer because what did we just say? It says the first 2 lines are parallel to the same line, so they are parallel to each other, but that just means that it contradicts the original given, because the original given says 2 lines are not parallel. So that means this, so the above contradicts, so statement 2 contradicts the given, which said that the 2 original lines aren't parallel. So therefore, all of that just didn't work out. Our assumption failed. So we say assumption is false. It failed. It didn't work out. So that means our original proof has to be true. Must be true. So for indirect proofs, you're trying to prove by contradiction, step 1. Yes. So we are trying to get something that says, I like candy and I don't like candy. Or, I am 5 and I am not 5. Or I am 7 and I am not 7. Right. So those are 2 opposing facts, and that's called contradiction. So that's the goal in all of this. So if you say the opposite of the proof and start with that and build upon it, you're going to get an error. And with that error, it's going to be an error to something that's given or something just mathematical. It's like, wait a minute, that doesn't make sense. So that means that opposite of the proof is completely wrong. So then the original proof has to be true. So we're not really showing the original proof directly. We're showing the opposite fails. So the goal is the opposite of the proof is going to be false. That means the original proof, without even actually showing it, is just forced to be true due to the fact that the opposite of the proof is false. So it's like a weird way of proving, but it's a different type of thinking. It's a different type of math modeling. All right, so then number 27, that was a weird one. We're going to do 15 and 16, and then we're going to go to hinge theorem. Yeah. So 15 and 16, those are the graphing ones. Okay, so that one was kind of like what we went over earlier. So 15, it says find the circumcenter. Oh, no orthocenter. Okay. So number 15, it starts at 0, 0. And 6, 0. And 0, 4. Ah, this is a right triangle. So this one, we should know where the where the circumcenter should be, and it should be on the triangle, on the hypotenuse, right, Kyle? Well, let's show it. Let's actually draw it. So if I find the midpoint of DF, you can count it or you can actually find it, two spaces, right, away from each other. So it looks like it's 0, 2. That's your midpoint. Oops. And then you would go, you would go horizontally. So that's your perpendicular bisector. Okay, then you would find the midpoint of DE, so between 0 and 6 is 3. You could count from the left, count from the right, 1, 2, 3, 1, 2, 3, right? It's the middle. Oops. So then, now you go vertically. Okay, ooh, that was pretty good. So that means this gray dot is your circumcenter, and that gray dot looks like it's 3 as your x and 2 as your y, and so therefore 3, 2 would be our final answer for circumcenter for number 15. So then the next one would be number 16. Let's see. Interesting point, Captain. 16. Let's see. 5, negative 1. 1, 2, 3, 4, 5. And that's called D. Then negative 1, 3. 2, 3. That's E. And then lastly, we have 3, negative 1. 3, negative 1. So this looks like it's obtuse. Let me just double check my coordinates. 5, negative 1. Yep. Negative 1, 3. Yep. 3, negative 1. Okay. So I'm going to connect the dots. This is going to be a little bit harder because I don't have really good grid paper. Look at how that's terrible. Okay, well, we'll do our best. I'm going to predict the circumcenter is outside the triangle. I just know because it looks like an obtuse triangle. So for this one, what I would have to do is I would have to find the perpendicular bisector of each segment. So D, this is F. So of DF, right, that's between 3 and 5. So the middle is 4. And then I would go straight up. And you're like, oh man, like I know it's going to be outside, but I don't know where. So it's going to be somewhere on that red line. Okay, perpendicular bisector. Now this is harder. So let's find the midpoint of EF. So let's find the midpoint a little bit more formally because I don't have the grid really well. So midpoint, we would add the x's and then divide by 2. So that is negative 1 plus 3 divided by 2. So that's 1. And then 3 plus negative 1 over 2, which is also 1. So my graph is terribly drawn. Okay, it is right here where the green line should have been. So this should have been my green line. Right, so 1, 1. And then I have to find the slope of EF. This is a little bit more involved. This one's a little bit more difficult than right triangles. So the slope of EF is you could do rise over run, but it's really hard to read my graph. So I'm going to do slope formula. which is, I'm going to make this, oops, yikes, x2, and I'm going to make this y2. So I'm going to subtract 3 minus minus 1, so I'm subtracting the y's, over negative 1 minus 3. That looks like 4 over negative 4, which means the slope is negative 1. But I need to do the perpendicular slope of negative 1, which is opposite reciprocal. And I would go and use 1 then. So I have to use perpendicular slope, which is positive 1. So I would go from this midpoint, up 1 over 1, up 1 over 1, and up 1 over 1. So it looks like it's going to hit this point, and that point is, sorry, I should have went through 0, 0. Looks like 1, 2, 3, 4, comma 1, 2, 3, 4. So our final answer to this really involved question is 4, comma 4. It's outside. So this is very more mathy because you have to find it using midpoint formula, and you have to find the slope of a segment and then the perpendicular slope. And that's right, it depends on the triangle. Medians could be perpendicular bisectors, etc. I believe that if you have an equilateral triangle, all sides are equal, then you will have, here's the median, it goes to the midpoint. But that midpoint, that median could also be the perpendicular bisector, and that could also be the altitude, and that could also be an angle bisector. So if you have an equilateral triangle, you can have all of the angle bisector, perpendicular bisector, all of the above, median and altitude, they would all be the same exact picture, meaning this segment right here. That's only if it is an equilateral. But other triangles, it's a maybe. It's not always the case. Medians, the most, oops, that's the color you can't see. The medians, what's required is it has to touch a vertex and it has to touch a midpoint, medians. But perpendicular bisector, it does not have to touch a vertex. It just has to find the midpoint, but it has to go perpendicular. So this one does not touch the vertex, but the median has to. Okay, so let's talk about hinge theorem. Okay, so hinge theorem, and then I'll do the quizzes. So hinge theorem is basically, we almost don't have enough information, like we don't have all the facts, but we're estimating, we're guessing that one segment is bigger than the other. So the quick, what's it called? The quick requirement is that you have to have two sides that are congruent to, like two pairs of congruent sides that are congruent to each other. So you have one tick mark each and two tick mark each. The hinge is always in between those marked angles. So that angle that I marked in red, that's the hinge. So this is what I'm doing. Yeah, Leon, this is exactly what I'm doing. So if I gave you just this fact, you're like, dang, I don't have enough information. Well, this segment is 5 and this segment is 7. So if I name this angle A and B using hinge theorem or converse of hinge theorem, we'll get to the details later of which is which, but you would look across the angle and you see 5. And then you look across 7 and you see B, right? So think about if 7 is bigger, that means angle B has to be wide. The opening of the angle has to be wider because you have to account for 7 to be fitting in there to make a triangle. So therefore, because 7 is bigger, that means measure of angle B prediction-wise, is going to be bigger. I don't know what angle, like what number it's going to be, but I just know in comparison to A and B, it's going to be bigger because 7 is bigger. So you look across. Oops, these are not big, these are small. Okay, so that's called an inequality, where one is bigger than the other, or one is smaller than the other. So if I have a triangle that's connected, right? Let's say I have 2 tick marks. You're like, uh-oh, I need a double tick mark. Well, this sometimes you have to put it in your the shared side, the reflexive property. And then now you're like, where's the hinge? Well, the hinge is between the marked angle. I'm going to call this angle 1 and angle 2, just so that it's easy to name. So once again, I'm going to put segments. Let's say 9 and 6. So therefore, 9 is bigger this across the street from the angle. So since 9 is bigger and 6 is smaller, that means measure of angle 1 will have to be bigger. Again, I don't know how many degrees it's going to be, but I know it will be bigger. Okay. So then sometimes you're given, let's say, like expressions like 3x plus 5, and then over here would be something like 20 degrees or something. So you're like, uh-oh, and then on you put some tick marks. So let's say these are congruent segments, and then this is double tick mark. And so you're like, oh, we have not enough information. Well, I will give you some more info. So let's make this 8 and 10. Sure. Okay, so now looking at, I'm going to call this angle 1 and angle 2. Since 10 across the street is bigger, that means 20 degrees will be bigger than the 3x minus 5. So you have to look across. Okay, so then our inequality, so now we don't look at 10, we don't look at 8. That's done with. That was just to help us determine which angle is bigger. So my inequality is 20 is greater or bigger than 3x minus 5. Then, and it'll say find the range of numbers that are possible values of x. So then from here, you would add, oh, I didn't pick, oh, I did. So you would subtract 5 from both sides. So you get 15 is greater than 3x. And then you would divide both sides by 3. So we get 5 is greater than x, or x is less than 5, right? So that's one answer. I told my students that this is a geometry thinking kind of question. You know, this is a right answer, but there might be some wrong answers in this because angles are always positive and angles are never 0. So that means we have to create one more inequality. This is a geometry thinking problem. 3x plus 5 has to be greater than 0 because all angles must be greater than 0. So here's why. Okay, if we don't do this, and if I pick a number that's less than 5, which is the answer, let's pick like -5. Right? If I pick x as -5, that satisfies this condition. But if I plug it in here, I'm going to get -15 plus 5 degrees, which is -10 degrees. We can't have -10 degrees. So that means there's some flaws to this answer. There's some wrong answers. So then once again, we have to set up another inequality, and we have to set it greater than 0 because an angle, if it's 0, it's non-existent. If an angle is negative, it's non-existent. So I'll do the math. I'll subtract 5, divide by 3. It's okay if it's a fraction. So then now I have 2 answers. These two together help me build a compound inequality from Algebra 1. So let me just kind of memorize these two numbers. Okay, okay, so I have x is greater than -5/3, and the other answer was x is less than 5. So I'm going to just switch this. I'm going to just switch the order. right? So if I put these together, if I merge them together, then it'll look like this. X, negative 5/3 is less than x, but the x is repeated, so I don't have to write it twice, and then it's less than 5, which just really means that it has to be greater than negative 5/3, or like negative 1.67, but less than 5. So if I just left my answer as x is less than 5, there's a lot of wrong answers in there. Yeah. All right, let me do the smallest side to the largest in a little bit. Yep. Okay, so let's talk about one more hinge theorem, which was kind of tricky on the quiz. So let me start going on the quiz side, and I'll go over the last two. I know this one I did with, I feel like, most of my classes the other day. Let me see. It was on the back side, and it was number 23. I don't know if anyone asked about that. Nope, I don't see it. So 23. This one is a thinker, okay, but I hope you guys will be okay. Please ask questions if you still don't get it. So here, this one was 93. Oh my gosh, and 87. And then these were like so. Okay, so this was the picture, and it was using hinge theorem, or using converse of hinge theorem, or whatnot, right? It asked us to compare and pick, is TE bigger than EA? Or is TE equal to EA? Or is TE smaller? So only one is appropriate. It can't be all three. It can't be both. Two. It's only one answer for this one. So in this case, oops, some glitches going on. Okay. All right, there we go. So this is showing that triangle TAM is isosceles because those angles are marked and then the segments are marked. Now I have to mark EM using reflexive property. And from there, my hinge is actually at angle 1 and angle 2. That's where my hinge is, because the hinges are always between the mark sides. So that's where we have to look at. And that's the reason why it's asking to look on the other side. So from here, if 93 is in the triangle on the left, and if angle T and A is the same angle, I told my students to make sense out of this, put a pretend number like 10 degrees and 10 degrees, or 20 and 20, or 30 and 30, or 4, it doesn't matter, but just pick any acute angle. And then from there, what we have to do is calculate what angle 1 is and angle 2 is. So I had very good discussion yesterday in my 6th period, and a lot of them volunteered and a lot of them shared, and they mentioned that since 93 is bigger, due to the fact that a triangle has to add to 180, that means angle 1 will be smaller. So measure of angle 1 will be smaller than measure of angle 2, because, I mean, we could do the math, right? If we add 10 plus 93, we get 103. And then we subtract from 180, we would get 73 left, like if we do the math. And then if we do 10 plus 87, that's 97, and subtract it from 180, oh my gosh, then that would be 83. Wait, is that right? I feel like my writing, I hope so. I feel like my math is not right. Hold on. Oh, 77. Anyway, so 77 and 83. Well, in comparison to those numbers, oh my goodness, sorry, this is becoming a mess. Like, we can definitely see how everything's falling apart. We can definitely see that 77 degrees is smaller. So now, okay, let me erase all of this. Let me go to a new one. Phew. So this was 77, making this the pretend number 10, and this was 83. So now we know for sure 77 is smaller, so that forces the opposite side to be smaller. 83 is bigger, so then the opposing side would be bigger. So what were the letters? I think this was T, E, A. So now TE is smaller or less than EA. Okay, all right. I feel like some of you guys need to do some individual chats, okay? I'm getting a little off task here. Okay, so then let me go over I did number 23 from the quiz, okay? So let's try 24 and 25. So 24, D is congruent to B, and DC is bigger than AB, and then prove that DC is not parallel to AB, but we have to do this indirectly. Okay, proof indirectly. And, okay. So you had to go back to chapter 4 for this one. All right, so step 1, every time you do an indirect proof, we always start off with the sentence starter, assume temporarily that opposite of the proof. So we would say DC is actually parallel to AB. Now, indirect proof is not feasible for everything, right? It's not appropriate for all kinds of proofs. It is appropriate if you can use the opposite of the proof and go further from that, okay? So, oh yeah, I'll do the range too. Okay, so then from here, I am going to believe what number 1 says. So I'm going to put tick marks on AC, AB, and DC. And from there, I'm like, ooh, these numbers are here for some reason, okay? Those are alternate interior angles. So I'm going to say I get to mark those. Boom, boom. So angle 3, if DC is actually parallel to AB like stated, right, then angle 3 is congruent to angle 4 by the alternate interior angle theorem. Way back when, they're alternate interior angles. They're now congruent. So then that's one fact, right? I'm going to stay on step 2. So another fact is angle D is congruent to angle B by Gibbon. So I'm going to put marking, and no, I did not do it yet. Okay, then I'll do one more marking. It's the shared side right here in the middle. So I'll say AC is congruent to AC by reflexive. POC, property of congruence. So I'm like, oh, this is from chapter 4 where we said triangle congruency. By the way, heads up, we're probably going to get some contradiction to that yellow circled item. Okay, so kind of like looking ahead. From here, I'm able to say triangle ACD, the one on the top left, is congruent to triangle CAB by, based off of my labeling, it looks like angle, side, or side, or side, angle. Okay, it doesn't matter what order. Yes, Kyle. So then afterwards, there's that 5-letter acronym that says everything is now congruent, all the marked, unmarked parts. So I can say, like, I have to choose wisely. I want to find a contradiction. I can say DC is now congruent to AB based off of CPCTC. By CPCTC. I'm not sure how strict or how your teachers are going to grade the next step. But there is one more step before step 3. If you recall, I know my students, we did this in our warm-up today. If you go from congruent to equal sign, that's called definition of congruence. Okay, so from here, we just found a contradiction. This is a contradiction to the given statement, which said it's actually bigger. Like, what? You can't be equal and then say you're bigger. Like, that's a contradiction. So, step 3 finally. Whew. Right? So, you can say DC equals AB contradicts the given. DC is bigger than AB, so you want to specify what's the contradiction. You don't want the reader, aka the teacher, to just figure out what you're thinking. You want to be very clear. You want to be straightforward. You want to be, make sure the reader knows what you're talking about. So you want to say, what is it that's actually getting contradicted? You don't want to just say contradiction. Like, we'll be like, what are you contradicting? What is contradicting? So don't assume the reader knows what you're talking about. So then now, because of the contradiction, the original proof, let me go back, not the original proof, the assumption, this red thing that I circled, dang, all of this turned into a failure. It gave us this result. So once again, this red circle right here, this gave us this result. Bummer, I didn't want that. So that means we say something along the lines like the assumption failed, right? So and the assumption, if you want to be more specific, you say DC parallel to AB, that failed, right? That part failed. So that means the original proof, which was slashed, right? It's not parallel, is true. Like, it has to be true. It's like must be true just by default. That's how indirect proofs work. It's by default that this original proof will be true as long as the opposite fails or false. Okay, I hope that makes sense. So that's number 24 and then 25. But let me, if I could do 21, because that was requested, and that will kind of talk about the third side and all the shortest and all that stuff. I will get back to number 25, the indirect logic proof, but I want to answer a few more people's questions too. So I'll do 20 as well. So 20 and yes. Okay. So I don't remember who asked 21. I will get to 20 very soon. So 21 first. It's the shortest to largest, and I know my students, we've been practicing a lot, so I feel like they have a good grasp, but it's always good to review. So step 1 is you want to find the missing angle. So let me just write down what's given. Okay, the missing angle in this MAT is 59 degrees. And then the missing angle in MHT is 63, right? They have to add to 180 for both triangles. Okay, anyway, so now I'm going to look at one triangle at a time. I'm going to look at the one on the green highlight. So 57 is the smallest angle. H is the smallest angle. Therefore, MT will be the shortest side. So this is S for short. Then 60 is the next angle, right? So then MH across the street would be your medium side, medium length. 63 is your largest angle, therefore HT is your largest side. Okay, now we do it again, but we're going to do it with the yellow triangle, MAT. So 59 is the smallest, so across the street, MA is the shortest. Okay, 60 is the next one, so AT is your medium. And 61 is your longest or largest number, so then MT is your largest. So if, we're growing against each other, MT is the same segment, but for the green triangle, it's small, And for the large triangle, for the yellow triangle, it's large. So if MT is the largest side for the yellow triangle, that means all of the other numbers, such as the medium and the small, will be even smaller. So, therefore, MAT is the smaller triangle. Okay, again, MT is the same segment twice, right? It's a shared side. So if MT for the yellow side is the longest side of your triangle in the yellow one, then everything else in the yellow picture is smaller. And I told my students if that conceptual reasoning is not making sense, it is advisable to make up numbers. And I tell my students, just pick any number, for the middle. So pick 8, whatever number. So if I look at my yellow triangle, 8 is the largest side. That means AT has to be smaller and MA has to be more small, right? Okay, then if I look at my green triangle, MT is 8 still. I can't change that anymore. But then 8 is the smallest side of the green triangle. Therefore, MH will be a little bit bigger and HT will be more big. So that'd be 10. Now we could definitely see what side's smallest to largest. So final result is MA is the smallest, or AM. Then AT is the next one. Sorry, I'm running out of room. And then MT. But you don't have to start all over. You don't have to say MT again. Like, just say it once. And then MH, because it's 9. And lastly would be HT. So that's number 21 from the quiz. How do I know MA is the smallest? Looking at this picture, 6 is the smallest. That's how I know from that. Or if you don't choose numbers, you have to decide, you have to reason which triangle, yellow or green, is actually smaller, and the yellow triangle is smaller. So I hope that answers your question, Jay. I know that's kind of like what I said earlier, but looking at this picture, just looking at the number 6, 7, 8, 9, 10, 6 is the smallest. That's why MA is the smallest. All right. Okay, so number 20, I will do that next, and then I'll do 20, what else is there? If AT is 60, and if HM is 60, how are they different lengths? If AT is 60, and if HM is 60, that's impossible. So Elena, good question, but that's impossible because if you look at the yellow triangle once again, the yellow triangle, it was ranked small, medium, large accordingly, right? So let me see if I can erase this bottom half and try it again. That's a really good, valid question. I like that. So delete, it's going. Okay, let me try to draw it again. So AT is 60 and MH is 60. So again, that's impossible, and here's the reasoning. So remember how this was large, medium, small. So if we are claiming AT is 60, then that means the shared side, the large, has to be a little bit bigger, such as like, I don't know, 62. It has to be a little bit bigger. Then for the other picture, let's say the green picture, right? We have a ranking of small, medium, large. Well, if we assigned this shared side as 62 as the shared side, and that's small, the medium cannot be 60. Like that's where I'm saying it's impossible because the medium has to be a little bit bigger than 62. So it could be 63, it could be 64, etc. So, who was the question? Who was the one? Elena, I hope that makes sense to you, okay? I said that was then equal to, uh-oh, Sydney, I'm not sure what you're talking about. How did you figure out which one came first and second in the middle, in the two middle sides? First and second. I'm not sure about what that question is either. Sorry, I'm like trying to interpret it. First and second. So I guess the takeaway is you have to, let me back up, yeah. You have to rank one triangle at a time, one picture at a time, and that's why I use the different colors. So once you figure out all three angles in one triangle, so let's say this yellow one, you see how there's the SML, the small, medium, large. Then you pause and you say, okay, let me do the same ranking system, start all over with the other triangle, small, medium, large. Once you achieve that goal, then you have to decide what triangle, yellow or green, is smaller, or if you can't decide that, then you can just play around with numbers, like just assign numbers to MT and make sure if, you know, that's the largest side, then everything else is smaller. Or if that's the smallest side, everything is larger. Ooh, Sarah, very good explanation. This is technically not hinge theorem. So that is probably why. This is not hinge theorem because there are no congruent segments. So I think that's why there's that disconnect. Elena, you have a great, I'm glad you're thinking it through and analyzing it, trying to think it through. But again, this is not hinge theorem due to the fact that we only have one tick mark. We only have one tick mark right here. And we don't have these. That's wrong. We don't know about those. So that's why, what's it called? We can't compare using hinge theorem. Okay. All right, I'm going to come back to this. I want you guys to think about it a little bit more, okay? So, Vion, I think we have to, I'll pause. I'll come back to this one. Draw the picture, copy it, take a picture right now, come back to it, and I'm going to answer number 20 that was requested from a little bit earlier, and then do a couple more and then call it a night, okay, guys? So, sorry, a little bit rushed at the end, but all right, so here's our 20 from the quiz. So the range of the possible lengths, find the range of the possible lengths. And I feel like if we did a little more simpler question, it would make sense. Let me make up a new one, okay? Let's say two sides are 5 and 12. If that's the case, then what would be the third side? Now, I showed a lot of patterns with my students, and eventually I said, there's a trick. The trick is it's going to be subtracting the two numbers, which is 12 minus 5, that's 7, and adding the two numbers, which is 17. So all the answers, all the third side could be between 7 and 17. Now, we didn't get to that right away. I had them like physically do all the chances. I said, okay, try 1, try 2, try 3, try 4, right? And then we made a whole list and we said, nope, 1 doesn't work. No, 2 doesn't work. No, 3 doesn't work, because you have to do the triangle inequality theorem. So 1 doesn't work because 1 plus 5 is not bigger than 12. So 1's out of the picture. And then finally, 8 worked because 8 plus 5 is finally bigger than 12. So that one works. So we're like, yay, we found one answer, right? And then we kept going, we kept going, we kept going. And then we're like, oh, 17 doesn't work. So then eventually the students found the trick. Okay, now here is the actual number 20. So that was a preface. Here's the actual 20. It says find the range of values. Here are two sides of the triangle are an algebra expression. So you're like, oh, whenever you see x, you want to solve, but that's not the goal here. So you have a triangle that's 7x, 8x plus 3, and we're questioning what does the third side have to be in terms of x, in terms of an algebra expression. So the third side, if we use the same idea as I just showed you earlier, you would subtract the two expressions. So 8x plus 3 minus 7x would give us x plus 3. That is first, okay? And then lastly, this one right here would be adding them. So if we do 8x plus 3 plus 7x, we get 15x plus 3. And so what's it called? This one is not useful if you don't know the trick, right? Like you don't want to do a lot of trial and error and all that stuff. So what's it called? So it said the length of the third side must be greater than x plus 3. However, it must be less than 15x plus 3. So those were the two results for number 20. Okay, angle possible lengths. Third side. I think I just answered that. Smallest to biggest side on overlapping. Okay, so I feel like we did these. Okay, so let me go back to something like 21 because I feel like that's still a little confusion, and then I'll do the indirect proof that I know I've been waiting. So I know a couple of you are still a little confused about this. So once again, this is not using hinge theorem. It's not enough information to use hinge theorem. We don't have the typical double tick marks with the angle in between. So that's unfortunate. We cannot use hinge theorem. 57 and 60. So once again, I'll try to use the same colors. You look at one triangle at a time, and then you rank them. So I remember this was large, this was small, I think, and this was medium. And then you look at the other triangle. I feel like I used green last time. This was small, this was medium, this was large. So how did I do that so fast? Well, again, 57 is the smallest angle, so across the street will be the smallest side. Okay, so eventually I told my students that if you're in a debate between small and large, and if you're trying to figure out which triangle is going to be smaller, the one that the shared side, if that's the longest, if the shared side, let me type it. If the shared side is the largest side of the triangle, you can't see this yet, then that triangle will be smaller than the other triangle. So that's kind of in words. So once again, the yellow and the green, there's a shared side. MT is the shared side. So MT is the shared side. And since MT is the largest side of triangle MAT, that means that triangle MAT has to be smaller than triangle MHT. Okay, and that's the case every single time. When you're a debate between the shared side, you have a small and a large, even a medium and a large, or even a small and a medium, like any combination, whatever is bigger that means technically that triangle is smaller. It's kind of like counterintuitive, right? But it's because everything else is going to be smaller if you think about it, right? Versus if the shared side, that's the smallest of all three sides, then everything will have to be bigger. And that's why the yellow triangle in this case is the smaller triangle. And then you just go small, medium, large, and then small, medium, large again. Okay, all right. Okie dokie. So last one is the indirect proof, and this was from our quiz. So there's probably like different ways of doing it, but I'll do the way that most students did. And I think it required 9 steps maybe, or even 10. And if you were like trying to be really good at like showing every single step, probably did it in 10 steps. So we had to do indirect, and this is a logic proof. Oops, let's go back. And we're trying to prove T. All right, so step 1, let's see if I could type it a little faster. So step 1, we say not T. We say the opposite. Okay, so that's step 1. Then step 2, we have to find a given that has a letter T, and it's if S, then T. That's the only one that has T. So that's step 2, given. So then I say, okay, I used that. That's gone. Oops. So bye. So now if I use these two together, step 1 and 2 together, now I can make a new result. And the result would be not S, using modus tollens. Modus tollens. I'm not sure how picky some of your teachers are. I know for my students, I do want you guys to write the steps you use to get that result. So I use step 1 and 2. So I'm thinking, uh-oh, now I need to find a not S. So I don't see not S. However, I see something with S. So I'm going to use this one as my next given. So number 4, I would use not R. If not R, then S. And that's given. Okay. And then now I have to use step 3 and 4. So this is where technicality happens. Now, if you didn't do this, I don't know how much your teacher stressed upon it. But for me, I was hoping to see not R. And if you didn't do that, if you just did R, I feel like that's okay. But this would result to modus tollens again. So if you just got R, right, like a lot of students of mine just did R, that's technically right, but I was hoping to see not R. Yeah, you could do contrapositive. If you did contrapositive as step 5, here's like an alternative, then, oh my gosh. If you did not S to R as contrapositive, then step 6 would be R, modus ponens. Yeah. So there are different methods. Thanks for bringing that up, Sarah. So then number 6, uh-oh, where did it go? I would say R, double negation from step 5. But if you skip that step, I don't think I marked it this time, but I was hoping to see that last time on the logic test. Okay, then number 7, you're like, oh, now I need to use another given. So the other given, perfect, I have R implies P. So then I write, oops, where's it? Number 7, R implies P, 7 given. And then my result would be modus ponens, P using modus ponens. 6 and 7. Okay, and then from there, like, oh, I gotta use my last given. Oh, something's wrong. So look at how, I'm gonna use my last given, number 9. There's the contradiction coming. Here's 9, not P. You're like, wait a minute, how can you say you're P, and then 1 second later, you're not P? Like, you are definitely contradicting yourself. So due to the fact that those are contradicting, I don't know how your teacher wants your ending. This is how Tira wants the ending. The ending for this 10-stepper would be, end result is T because of the contradiction from step 9 and 10. That's as far as I needed for that one. So again, I think Sarah brought up a good point. There is a different method where you can do contrapositive, which would change the game a little bit. So if we did do contrapositive, which I actually did too as a backup plan, here's the alternative. Step 5 was not S implies R contrapositive. And then, sorry, I can't see this yet. Then R, this is the exponents, 3 and 5. And then 7. Sorry, you can't see this. I'm just still typing. Oops. 8. So if you did contrapositive, there is no modus tollens. No, never mind. Wait. You don't use modus tollens twice. You just use it once. 9, not P, given 10T. Okay, so here is the alternative. Oops. The alternative to the other proof. So here is the alternative. So step 1 through 4 might be the same for everyone. And then you could either go to step 5 going down, or you can go to step 5 going to the side. So both worked, I guess, both 10 steps. How many points for my class? It was 50. I'm not sure how many points it is for our other classes, but just remember, like, just in general, your percentages to make up a grade in a class. We have tests are 80%, and there's approximately, I feel like each test is almost worth 10% of your grade, something like that, versus quizzes are worth only like 5 to 10%, and then like homework is another 10%. So if quizzes are only 5 to 10%, and even if it's 50 points each time, and like, 20 points each time, like those are all going to get averaged out, right? So I don't know how many chapters we have so far. We have like 5 chapters, right? So let's say we have all of these numbers, right? So let's say we had a 50, a 50, a 20, a 50, and a 30. So then this grand total is 200 points, just in the 10% or 5% category. And so this 50 pointer, if you only got one wrong, let's say you have 199 out of 200 points, like that in the 10% category, that 1 point's not going to do much, if that makes sense. It's not going to affect so much versus like 100 out of 200 points. It will affect it where you got 50%, right? Correct. So then therefore, if the quizzes are 10%, then now you're down to 5% lower of your score. But 99 out of 200, like that's not going to be 5% lower. It's going to be, maybe like 0.1%, like nothing really. So, just FYI, is there going to be distance formula? You could use it. You don't have to. The only reason why you'll use distance is if you had to find the midpoint, or I don't even know. I feel like you don't need distance, to be completely honest. Midpoint maybe, but distance I don't think so. I think midpoint and slope, if anything. But yeah, alrighty. So I'm gonna pause it. I'm going to put the link. So stay if you want the link to rewatch it. You're welcome. So I know I didn't get to answer everyone's questions, but I think we got a good basis. And let me go to the link page and get you the code.